Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ETC department and we are discussing the subject called programming for problem solving. And yesterday we have started with the for loop. I feel that the for loop requires one more lecture's attention, more 20 minutes of our attention. We haven't discussed about the different forms of for loop and a very important topic called the nested for loops. So today we are going to see how many ways you can initialize a for loop, and then we'll see how a nested for loop is applied. So let's go to the notes. Now, various form of for loop. Now, instead of num plus plus, that is your updation, that is increment or decrement, you can always use num is equal to num plus one. Obviously, your unary operators, that is your pre-increment, pre-decrement, post-increment, that is plus plus minus minus, are just the form of like if it is written there plus plus num, then it always means that num is equal to num plus 1. So you can always do like this. And also I want to state that we have incremented or decremented by one only in one pass of the for loop. Like if num is our variable which decides how many times the loop is going to pass, and as you can see here in this for loop statement, num is incremented by one every time the loop makes a pass. This is not mandatory. Your loop can make pass by incrementing twice, let's say by 2 or by 3. So it could be that num is equal to num plus 5. Okay, in that case this loop will only runs for one time, or if it is, or num is equal to num plus 2, in that case it will run for 5 times. Okay. So it is up to you how many what you want, or by what amount, by what step you want to increment your conditional statement in. So there is no constraint, no restrictions by how much you are going to increment your variable, your for loop variable, every time the loop makes a pass. Okay. Now, in the next line, you can see that the variable, that is RAM, or let's call it num, is initialized with 10 and of type int. Now, inside the for loop, we have uh, we have blanked out. We have left the field for initialization to be blanked, and then we have used num for the condition, and then we have incremented the num. So this is a valid representation of the for loop because initialization of the num has already been there, has already been done. The num has been declared as an integer variable and its initial value is 10. So there is no need for that. Okay, you can always left it out if you want. Okay, but that is not the standard practice. The standard practice is to declare the variable outside the for loop and then initialize inside the for loop. So these are the few forms which are very much, let's say, valid. Now, even though we can skip the initialization part, but semicolon before condition is a must. Okay, so as you can see, semicolon is a must, which without which you would get a compilation error. So, so these are few of the for loop statements which are valid. You can skip this statement, this increment decrement part here, and you can put it here. So this is also valid, but that is again not recommended because what's the use of putting that in here? It is, if this decrement statement is as we have already defined, is going to be your last one. Okay. Okay, so let's move ahead again. So we can do this, and these are all forms. You can write it out on your notes. But I would recommend to go by the basics because that is the common convention. Okay. Now let's get to the main topic, that is nesting of the loops. Nesting of the loop means the loop inside a loop. Okay, it means loop inside a loop. For example, As you can see, we have a for loop initialized, and inside the for loop, that is inside the braces, another for loop has been initialized. Okay, another for loop will be initialized. So this is a type of nesting of the for loop. We will see an example of this for loop in a second. Let me first tell you why these are, or where you can apply them, where you can. Okay, so let's say we have a matrix which prints the numbers, that is 4 by 4 matrix, let's say. So 1 comma 2 comma 3 comma 4 and 5 comma 6 comma 7 comma 8 and, and then 9 comma 10 comma 11 comma 12 and then 13 comma 14 comma 15 comma 16. Okay, as you can see, if you put these numbers in a bracket, you will see that this form looks like your what can you say, a 4 by 4 matrix. Okay, it's a 4 by 4 matrix in action. So these are the 4 rows: your first row, second row, third row, and your fourth row, and then your first column, second column, third column, and fourth column. So how do you traverse through each of these numbers in a matrix? By traversing, I mean you reach out to each of the member of this matrix, or how do you print that? Now these kind of problems are efficiently solved by your nesting of the for loops. One for loop that is the for loop which is outside will take the control of your rows, and the other for loop, that is the inward for loop, will take control of your columns. So the first for loop will take the control of on which row you are. So I'm on row second at present, and the second for loop will then take you to the each element, that is row second column 1, row second column 2, row second column 3, row second column 4. So this is how your for loops will be used. So the first for loop will take the control of on which row you are, and second for loop, that is the for loop inside the for loop, that is the nested for loop, will take control of on which column you are. So that combination of row and column will actually take you to the each and every element of your matrix. Although this is not the only application of your nested for loop, but that is the very basic application of for loop which has been taught over the years to make the students understand how a for loop can be, how nested for loops, or how a nested loops could be understood. So we'll head to the IDE and we'll see the first hand experience how we can implement the for loop. Let's try to implement a nested for loop. Now inside the main, as we have to initialize two for loops, so we are going to use two integer variables. Okay, so let's take one I and j. Okay, and uh, we'll try to print the values of the matrix we have just let's say we have just printed here. Okay, we have just printed here. So 2 plus 1 3 and okay. So let's try to implement this. So the first for loop will take the control of the rows. I'm going to print the I'm going to print the matrix in the form of 4 cross 4. That is, number of rows will be 4 and number of columns will be 4. Okay. So I is equal to not 0 but 1, and let's say I must be less than equal to 4 and I plus plus. So this for loop will traverse from each rows. That is, when I is 1, we are at the row 1. When I is equal to 2, we are at the row 2. When I is equal to 3, we are at the row 3rd. And when I is equal to 4, we are at the row number 4th. Okay? I think you have understood what I am trying to say now. Okay. And next, let me initialize one more for loop for you. This time, the variable that is being used here is j. Okay, so j again, the j will be less than equal to 4 because the number of columns I have chosen to be in my matrix are also equal to 4 because I have chosen to print 4 by 4 matrix. You can choose any number of rows or any number of columns. Okay. Then again j plus plus, and I'm going to print. Let me also initialize a value or variable here, that is k, whose initial value is 1. Okay. So now what we are going to do is, that is printf. Now I think I got the wrong printf, and then for the tab, and then percentage d, and let's say the value k initial. Okay, and every time it make a pass, I will increment the value by 1. Okay, plus plus. Okay, and I also want to print this value like in a different line, like first row will be printed in first line, second row will be printed in second line, third row will be printed in third line, and like that. So I will also insert a printf statement, printf, and let me pass space for new line. Okay, we have already seen what backslash n can do. So I'll try to save this first. Oops, I have to save this, not. So 26th will be the new line. Okay, so I'm going to run this. Let's see if we have succeeded or not. To wait for some more time. And yes, there it is. As you can see, the representation of the printing at the output at the console is just like a matrix. So the first row 1, 2, 3, 4. Second row is 5, 6, 7, 8. Third row is 9, 8, 11, 12. 13, 14, 15, 16 will be the last row. After 4, the next 4 values are printed in a next line because of this printf statement. So what is happening here? Let me tell you line by line. These are two for loops. When the control enters to the first for loop, value of I is equal to 1, and as the value of I is equal to 1, it is less than 4, so the condition is true. So we'll get inside the for loop. Okay, this outer for loop. Now when we go inside, the first statement that we have encountered is another for loop. Inside the for loop, a value of a variable j is initialized equal to value 1, and then the condition will be tested. Now 1 is obviously less than equal to 4, so the condition is true, so we'll go inside that for loop. So we are inside a for loop and then a nested for loop, and now we are in at this statement. Now this statement will print the value of k. Now k is a variable whose initial value is equal to 1. The 1 will be printed here. After this printf statement, the value of k is incremented by 1. That is, now it has become 2. Now we have reached at this point. At this brace, the last increment decrement statement will execute. That is, the value of j will increment from 1 to 2. Okay. Now again we'll go here. The value of j is 2, which is now less than 4. Again we'll go here. The printf statement, it will print the current value of k, which is actually 2. So 2 will be printed here. And in that way, the value of j will be 3 here and value of j will be 4 here. after the value of j is 4 in this particular pass, the value of j will be incremented by 1. That is, the value of j will become 5. We'll go there, condition will be checked. Now condition will be checked. In that case, the condition will fail. It will came out to be false. In that case, this particular loop will be terminated. Now we have reached at this printf statement. This printf statement will just push you to the next line. So after 4, we are at the new line. And again, the control will shift to this for loop. The value of I is incremented by 1 at this point. That is, from 1 it has become 2. Now 2 is less than equal to 4. Yes, the condition is true. We are again in the for loop. Now after getting inside the for loop, this for loop is again initialized. Let me tell you, this for loop will again be initialized. This is a new for loop. This is not an old for loop. Again, the value of j will start from 1. Then the condition will be checked. Again, we will start printing the values. Now the value of k is not equal to 1 at this point, because from the last inner for loop, the value of k has already become 5. So 5 will print here. Again, the 4 values will be printed. Again, this for loop, the inner for loop will terminate. Okay, after termination, we'll reach to this line. It will push us to the next line. Then we have reached at the third row. The value of I will be incremented from 2 to 3. Again, we'll go through the same process. So in that way, until all the value of I will exceed 4, this particular procedure will go on. So that is how your nested for loops will work. So I think you have got the idea how you can use your nested for loops, or how you will work. There is no limitation on the nesting of the for loops. I have shown you only one nested for loop, that is a loop inside a loop, but you can nest as many for loops as you want. That is for loop inside a for loop inside a for loop, as far as you can understood what is happening there, or you can control manually how you can manage the complexity. Okay, so I'll end this lecture here.